Can you hear me? Can you hear me out?
Yes.
Okay, so we are going to apply what we've done under moment to solve problems. So I'll put down a couple of questions on the board so we try, okay, solving them. The first one is that, so I'm writing the question on the board. I hope you can see. So example. Let me read this out to you before. Is that the first example is that the forces acting on the rods.
Mr. Edia, please, the screen has frozen.
I'm dictating the question first. Okay. Then give you the drawing. That the forces acting on these rods are in equilibrium. The forces acting on these rods are in equilibrium. Now the question says that find the value of the unknown forces, okay, and the distance. Find the value of the unknown forces and the distance. The first question is this. We have a bar. I'm coming. Okay, so the first question is this. We have the bar and then the forces around the bar. We have 8 grams. We have another weight, 6 grams. And the pivot is placed at, then we have this 20.
Mr. Edia.
Hello.
Okay.
Hello.
Please, the problem has been solved. Thank you.
Okay. Then the 8 gram is at a distance of 30 centimeters from the 6. Then the 6 gram mass is at a distance of 50 centimeters from the pivot. Then lastly, the 20 gram mass is at a distance of X. there is a force P, reactional force P on the pivot. So obviously this question will require that you find the distance x from the 20-gram mass. Okay, because we have the masses and the distance from each other and the pivot. We don't know this distance x, and we are to find it.
Mr. ATM,
Now, Jemfua,
please, I don't know if it's only me, but then the board is quite blurry. I can't really see the value.
the first.
Yes, please, Mr. D, I can't see anything.
Oh, it's a network. Okay, let me take a shot and send to the platform. Okay. Okay.
Yes, please.
Yes, please.
But what about the rest of you? Can you see?
No. No, please. No, please.
Then I'll.
Yes.
And then if you can see, please rejoin. Okay, just rejoin to see if it will solve the problem for us. Okay, but I've taken a shot of the question and it's posting it onto the platform. I've done so.
Yes, please. Thank you.
But rejoin, if you can't see, rejoin, and then let's see if that will solve the problem for us. So we have this arrangement. The forces acting on these rods are in equilibrium. Okay, meaning that the net force acting on the system is equal to 0. Now find the value of the unknown force. Okay, there are a series of questions. With regards to this particular question, what we have to find is the distance x. But there are other questions where you find forces and then x. Please, are we okay? So with this particular question, we are only looking for x because that's the missing link. Okay. So how do we find? Okay, we are okay. We are looking for x and p. We are looking for x and p. This p, the reactional force produced by the pivot, is not known, and then x. Okay, so how do we solve such a problem? Okay, so solution. We apply the laws of or the principles of movement here. What is the first principle of movement? Yes. What's the first principle of movement? Can somebody share it with us? Abna Yabua, what's the first principle of movement? Abna? Yeah, Abna's network. Oh, Abna, hardly can I hear you. Let me call somebody else. Akofala, what's the first? Hey.
That for the bar to be in equilibrium, all the forces will be equal to the force.
Hey, the feedback I'm getting is weird. Okay, so the first principle says that at equilibrium, The first principle says that the sum at equilibrium, sum of upward forces must be equal to the sum of downward forces. So if the sum of upward forces must be equal to the sum of downward forces. Now let's come to the diagram. We have three forces or masses acting downwards, and it should be equal to the force upward. So it implies that P must be equal to 8 plus 6 plus 20, giving us 34 grams. So P is equal to 34 grams. Now, once the statement is about forces, you can either leave your answer in this or convert this to weight or force. 34 divided by 1,000 times 10. Or simply, we can convert this to weight by multiplying this by 0.01, and the answer will be the same. Please, are we fine? Are we okay? So it means P will be equal to 0.34 Newton. Please, are we okay? Eliana?
Please, I don't understand.
Eliana, which part?
The addition of the masses.
The what of the masses?
P is equal to 8 plus 6.
The first law of principle of moment says that to obtain equilibrium states, one, sum of upward forces must be equal to the sum of downward forces. Okay, so either you convert this to forces or you can sum them up and then later convert. So we look at this. We have three masses acting downwards, and it should be equal to whatever force upward. When we look at the upward forces, we only have P, the reactional force produced by the pivot. Elena, are you okay? So if the sum of upward forces must be equal to the sum of downward forces, then P will be equal to this plus this plus this, which we summed up and later converted them to weights. So P will be equal to 34 grams or 0.34 Newton. Eliana, are you fine?
Yes, please.
So we are just applying the principle of movement. We are just applying the principle. Hello.
Mr. Adria, please, when you are done, can you send a picture of the solution to the group? I can't see. Yes, please.
I hear you. Okay. Anita, is that you?
Oh, please. This is Mirabel.
Mirabel, try and rejoin. You try, let's see. Okay.
Okay.
So that answers the first part of it. The next part is to find X. How do we determine X? We will determine X by considering the second principle of movement, which says that the sum of clockwise movement the sum of clockwise moment must be equal to the sum of anti-clockwise moment. So sum of clockwise moment is equal to the sum of anti-clockwise moment. So here, let's identify which turning effects would give us clockwise and which turning effect will give us anti-clockwise. If we look at the 20-gram mass, it will turn this way. So this is clockwise. Okay. This is clockwise, meaning if I should hold this and then pull the thread to the direction of the weight, it will turn in the direction of the clock, clockwise. Then 8 gram and then the 6 gram would be anti-clockwise. This will turn in this direction, so will be the 6 gram. So this is anti, this is also anti. Now, if a force is directly on the pivot, it will give no turning effect. So P will produce no turning effect because the perpendicular distance to the pivot is 0. Please, are we okay? Hello, are we fine?
Yes, please.
So let's look at, we only have one force, or this giving us a clockwise moment. So 20 gram. But let's convert this to kilogram. It will be 20 divided by 1,000. Okay. Then times 10. We are converting the masses to force. So mass times gravity. Okay, but we first need to convert this to kilogram, or simply, if we want to convert grams to weight direct, 20 gram times 0.01. Okay, and that will give us the force. What about the perpendicular distance? The perpendicular distance the force makes with the pivot is x, no times x. So that will be 8 for the clockwise moment. It should be equal to the sum of the anti-clockwise moment. So 8 gram times 0.01. Okay, converting gram to weight times the perpendicular distance 8 gram makes with the pivot. Please, what's the perpendicular distance? What's the perpendicular distance here? From the
80 centimeters.
Come again.
80 centimeters.
Good. So 80. So times 80, but we need to change 80 centimeter to meter. So 80 times 10 to the power negative 2. We are only here, we are converting the mass to weight or force. We are also converting the distance from centimeter to meter. Okay. So plus the 6. 6 times 0.01 times the perpendicular distance is 50. So 50 times 10 to the power negative 2. So let's put them together. This is equal to 0.2. 0.2x. 20 times 1/100. Okay. This is also equal to 0.08.
Mr. Dia.
Hello.
Please, I'm a bit lost at this step.
Why?
I understand this that the sum of the clockwise movement is equal to the sum of the anti-clockwise,
Okay.
but okay, I'm especially how we
Okay, hold
we
on.
show that.
I get your problem. Please, I want you to convert 20 gram to kilogram and then convert the masses into weights. Okay, by multiplying by the mass expressed in kilogram by 10 meter per second squared. Okay, so do that for 20 gram, do that for 6 gram and 8 gram for me.
Mr. Ja,
Hello.
please, the latter part, what the after the 6 times 0.01. Please, what?
I get you.
I can't see that.
Okay. Okay, that is 50 times 10 to the power negative 2. Can I clean the top side? Can I clean the top solution, the first part? Can I?
Yes, please.
Good. So to make the understanding simple, let me use another approach. Let's individually convert this to weights. So convert 8 gram to 8 weight for me. So you have to convert 8 gram from gram to kilogram and multiply by acceleration due to gravity. So do that for me. Somebody should also do that for 6 and then do that for 20. Okay. What did you get for the 8 gram converted to weight? Hello.
0.08.
So this is 0.08 Newton. Obviously, this will also be 0.06 Newton. Then what about the 20 gram?
0.2 Newton.
So 0.2. So all that I'm saying here is that if you have masses given to you in gram, to convert them to weight, don't waste time converting it from gram to kilogram before you multiply by 10. Just multiply the masses in gram by 0.01 Newton and you convert it from gram to weight direct. And that's what I've done here. Are we okay? So, summation of clockwise movement. So, summation of clockwise movement, this gives us clockwise. So, we have 0.2 times the perpendicular distance. And the perpendicular distance is unknown, x. So, we have 0.2x. Then let's look for summation of anti-clockwise moment. That will be equal to, this will give us anti-clockwise. So 0.08 times the perpendicular distance. From this force to the pivot, the distance is 80 centimeter. Let's change 80 centimeter to meter. Please do that for me. 80 centimeter to meter. That will be
0.8.
So this is 0.8. And that's what I've done here. I just use Professor Senti. Okay, plus 0.06 times the perpendicular distance. And that is 50. Change 50 centimeter to meter for me. 50 centimeter to meter. That is what? 0.5.
0.5.
So 0.5 meter. So if for equilibrium, so you let me clean this because we've made it simple here. Anita, are you there? Mirabel, are you back?
Yes, please.
For equilibrium state, some clockwise moment must be equal to summation anti-clockwise. So equate the two. You had 0.2x to be equal to, I have multiplied this by this and add it to that for me. So 0.08 times that times 0.8. This will be equal to 0.06064 plus 0.06 times 0.5. And this will give us 0.03. So we have 0.2x equal to this plus 0.064. And this is 0.094. Are we okay? So to find x, you divide through by 0.02. X therefore is equal to this divided by 0.2, which is 0.47 meter. What it means is that the distance from where the 20-gram mass is to the pivot is equal to 47 centimeter. Is equal to 47 centimeter. So that is where this 20-gram mass has to be placed from the pivot so that we could get a situation of balance or equilibrium. Are we okay?
Mr. Edia,
Uh-huh.
please, is it a rule that all the movements at the left-hand side are always anti-clockwise?
No, this is per what I have given you, per the question I have given you. Okay. So I'll give you another question.
Please, I don't please.
Come again.
Mr. Dua, please, I can't see the board clear. I can't see the board clearly.
Yeah, Yani, let me take a shot and then send it to the group. So with regards to this question, we have two forces, okay, at the left-hand side of the pivot. I'm coming to give you another question. I need to have sent the solution into the group, okay? All right, question 2. Question 2. Question 2. Let me only clean the masses. So over here, we have